what do you tend to prioritize when considering trade-offs? Do you look hard at security? Do you look really hard at maintainability long-term and readability? Are you really like looking deep into gas golfing and gas optimizations because you know this is going to be used so much, and a lot of things are going to be interacting with L1 Ethereum, but would love to understand how you process different trade-offs like that.
For us, security is always the highest priority. It doesn't matter if your contract is fast, if it gets hacked, like it's by far the highest priority. So everything else is kind of secondary to that. After that, I would say this balance between code readability and sort of gas golfing, where we would usually do first pass where you kind of like code everything out such that it's the sort of the nicest for code readability and stuff like that. Then you would do sort of a second pass where you're looking for very hot paths. We don't optimize overly everything. You more like identify where something's going to be used, such as say the transfer function on an ERC20, very heavily used. So you would heavily optimize that for gas usage. So yeah, that's kind of how I look at that usually.
Hello and welcome to another episode of the Devs Do Something podcast. Today's guest is Sam MacPherson, a protocol engineer with the MakerDAO engineering team. In this episode, we talk through a variety of really fascinating topics related to how Maker approaches their engineering process. And we specifically get into some of Sam's thoughts on smart contract development, security, and his work with multi-chain Maker. So we go through things like Maker teleports, bringing real-world assets on-chain with Maker and some of the technical considerations in doing so. We walk through how Sam has educated himself about some non-technical items that have been relevant to his work with the Maker team, including how to manage risk properly. He's learned a lot from some of his teammates over in the Maker ecosystem, and we call out a few particularly helpful resources in the episode for those that are curious. We also talk through some of Sam's favorite smart contract design patterns. We walk through how the team has approached naming conventions. We've walked through what their specific process is for shipping new features. And we get Sam's thoughts on things like inheritance, security, and just how to be a good smart contract developer in general. So if you write Solidity, if you're interested in becoming a really good protocol developer, this episode is going to be great for you because you're going to learn from one of the best devs in the space, working on one of the most highly regarded and high quality teams in this space. I hope you enjoy. All right, so we're here with Sam. Welcome, Sam.
Hey, it's good to be here.
Good to have you. So we'll get into a lot of different technical topics later, particularly around your work at Maker, some of the multi-chain things you guys are up to, and more. But the first question we like to ask on these podcasts are, how did you get involved with Web3 and Ethereum development?
Yeah. Okay. So I first kind of got involved in crypto I came in the 2017 bull run, just sort of as a passive investor, looking around for interesting stuff. So ETH was sort of the first thing I gravitated towards, and then just in exploring sort of the Ethereum blockchain, I stumbled across Maker in January 2018. I thought it was the most interesting project at the time. So at that time, still just sort of a passive investment, but I just was quietly learning about it over several years. The silent observer type in the community forums and stuff like that. And then, I just took a more active role as I sort of understood things, and there were sort of more options available to like tweak in governance and stuff like that. We could actually make decisions in the DAO. And then sort of this culminated in me learning. So I'm a programmer by trade. So previously I've done video game development. So I decided to pick up Solidity and smart contract development in August 2020 and just started contributing to the project. And then shortly after that, I was invited to join the DAO protocol engineering team as it was initiated. Yeah.
Nice. I love it. So a lot of your work, it seems, and correct me if I'm wrong on this assumption, I'm just going based off of recent talks you've given and some of your public content, but it seems like you've been involved in some of Maker's multi-chain efforts. Can you
Yes.
walk us through some of the vision and strategy behind multi-chain Maker, and then we'll dive into some specific areas of that afterwards?
Yeah, sure. So yeah, that's the area that I'm most focused on right now is basically getting the accounting and sort of the Vault engine and all this kind of stuff going multi-chain. Specifically, we're starting with L2s. So what this basically looks like is that when we are sort of finished with the initial rollout with Maker Vaults and stuff like that, you'll be able to say go on Oasis and then go on optimism for your chain, and then you'll be able to maybe take a loan out against your OP tokens or something like that. You'll be able to mint DAI there that is fungible with L1 Ethereum DAI. So that is the primary effort, and once we get there, we'll be able to have all the features attached to Maker beyond just the Vault engine, such as the peg stability modules and the D3M and stuff like that.
Nice. And in doing a bit of research on how this architecture looks, my understanding, and please correct this if it's wrong, is that you have obviously like the main master Maker instance on Ethereum L1, and then you have these other sub instances on separate side chains and layer twos. And the idea is that there is a bit of a separation of concerns where you have maybe not all of the risk for the entire Maker ecosystem exposed on Optimism or Avalanche or another sidechain. Instead, it's these separate instances designed to keep the risk not centralized, but decentralized to these separate environments. And things are built in that way. Is that a correct summarization of how that works?
Yeah, exactly. I mean, Maker, first and foremost, we need to protect DAI holders, protect the protocol. So everything we do, every sort of collateral we onboard or go to some chain or something like that, we need to set debt ceilings so that in a worst case scenario, it won't destroy the entire project. We will just have to sort of take a loss. And so for, yes, this master slave kind of separation, Ethereum is the source of truth for everything. Maker is anchored on Ethereum. So you can kind of view it as, especially with gas prices getting higher and higher, it's less going to be sort of retail users using Maker master instance, and more so on these L2s and side chains and stuff like that. And then you look at Maker on L1 as sort of a settlement layer where we basically just need to periodically adjust the accounting to make sure that it matches what's going on L2s and side chains to win within some like a reasonable time frame, basically.
Got you. And then what other than the debt ceilings, are there any other major differences in the instances of Maker on these separate side chains that are off of L1 Ethereum? I would love to understand how the actual like what the specifics of the contract architecture looks like if you're willing to share that.
Yeah, so it is actually pretty much a duplicate of L1 Maker. So that's what we're kind of aiming for, because we have so much like legacy code that we've built and heavily audited and stuff like that. We don't want to have to rebuild everything. So you can think of it just sort of, yeah, there are some subtle differences, but to the end users, it's just a complete duplication of Maker on these chains. But the difference is it's not like we can just sort of deploy sort of an isolated instance because we want the whole point of Maker is basically DAI is the product. We want the DAI to be fungible with L1. So if we were to deploy an isolated instance, it would be like an entirely new version of DAI, and we don't want that. So there's a lot of time and effort that has to go in to make sure that the DAI on these other chains it's not exactly fully fungible, but it's like for all practical purposes, it is fungible to the users.
Mm-hmm. And this is actually an interesting segue into your work on Maker Teleport, right? So Maker Teleport, I guess, can you just explain what Maker Teleport is and how it fits into this vision of making DAI fungible across every single environment?
Yeah, so Maker Teleport is a new product offering that we have attached onto the Maker Core. And the idea is that as we sort of extend debt ceilings to these chains and stuff, we can use the Maker Oracle network, which we are already trusting to provide price feeds and stuff like that, to basically attest to events that have occurred on other chains. So with Maker Teleport, basically users will be able to burn their, let's say you're on Arbitrum, you want to go to Optimism, right? If you were to do this using the native bridges, you would have to wait 7 days at least for the fraud window on Arbitrum to go to L1 and then back up to L2. Maker Teleport skips this entire thing. You basically send off an event on Arbitrum, burn your DAI, and then so the Oracle network watches for this event, and they can see, okay, this user has said that they want to transfer, say, 100 DAI from Arbitrum to Optimism. I've seen that. It's all good. They then provide attestations to that user, which then they can go onto the version of Teleport on Optimism and request to mint that 100 DAI, which will later be settled using our sort of bulk settlement construct that will settle it out on Ethereum L1 later.
Gotcha. So are there like, basically every time I'm interacting with Maker Teleport, I'm interacting with that master instance effectively on L1 Ethereum, right? Which is saying, all right, mint DAI on this extra chain, burn DAI on the main chain. And that's how some of this is actually being processed from chain to chain and managing liquidity. Is that accurate?
So you actually don't interact with L1 at all. And this is kind of the goal, right? You can view L1. I don't know if you've ever played that game as a kid where you're jumping between the couches and the floor is lava. Think of Ethereum as lava. You don't want to touch it if you're a user, right? You just want to jump purely from one chain to the other. So you'll be interacting entirely sort of with the slave instances and emitting events there. So basically the protocol is what will bulk settle sort of the actual underlying accounting at a later date. But with Maker Teleport, you're essentially taking a loan out on Optimism, which is it's backed by the guarantee that in the future the DAI will move from the Arbitrum escrow on L1 to the Optimism escrow on L1.
Gotcha. Yeah, Fran from our team at Superfluid loves to say that L1 is lava. It's like his favorite thing. So he's going to be pumped that you just said that. Okay, so if I'm thinking of bridging in this like other paradigm, right, with like connects and stuff, right? If they're using an optimistic bridge, right, I have an idea of what that exact transaction flow looks like. Rahul, the CTO at Connects, actually came on here and walked through that specific transaction lifecycle. So it might be good just to juxtapose that. You already kind of went through some of this, but it'd be good if you wouldn't mind just talking through like the exact life cycle of a transaction in which, let's say I want to bridge 100 DAI on Arbitrum to Optimism. Like, can you walk through like step by step what that would look like?
Yeah, sure. So there's kind of two parts. There's the user part that uses the Oracle network, and that doesn't touch Ethereum. But then there's sort of the later settlement part, which sort of updates the accounting on L1. So what are bridges? And bridge is kind of an overloaded term. I kind of separate them into what I call more messaging layer bridges, which would be something like Nomad, Optimistic Bridge, or various other bridge providers. And so actually an example of a messaging bridge is the rollup itself, which is the highest security bridge you can possibly have, because it's like integrated with how the rollup works in and of itself. So what Maker does, our bridging system is more of like at the application layer, where we can just hook it onto any sort of arbitrary message passing bridge. And so for the rollups, we will always use the native message passing bridge, because we want the messages, we want the highest sort of security when we're extending debt ceilings out to these rollups. And so the native messaging bridge is a natural fit there. I mean, of course, the downside is that there's this 7-day delay for optimistic rollups. So to get into the message flow, we kind of use two messaging bridges. So we'll do settlement on the native bridge, but for the user side, we're using the Oracle network. It's sort of the simplest possible design of a messaging bridge, which is a completely trusted one. We completely trust the Oracle network to tell us like they can sign whatever they want technically, but we need to sort of trust them collectively that they will not do this. So yeah, but since the Maker system as a whole kind of relies on these Oracle networks, this Oracle network to provide the price feeds, the trust assumptions are roughly the same for Maker Teleport. So I went through the user part. I guess the settlement part, I can go over that quickly. So what that looks like, let's say I have a user and I've transferred my 100 DAI from Arbitrum to Optimism. There is now delta between the L1 side of these escrows, which contains the backing DAI for the L2. There is now 100 DAI difference between these that in the Arbitrum one that should move to the Optimism one. So once a day or something like that, we will have a keeper call the Arbitrum bridge and say, hey, there's like 100 DAI that needs to move from Arbitrum to Optimism escrow. And so that will send a message through the native messaging bridge down to L1. And we're in a 7-day delay there. And it will move that 100 actual primary DAI on L1 from one escrow to the other and sort of settling out the accounting there.
What kind of delay does this look like for the user? So, a user wants to bridge from Arbitrum to Optimism. Like you have this sort of finality, right, that comes with the bridges. But is this something that, basically like a user can use, within seconds, or what does that delay look like?
Yeah, we're looking at sort of on the order of like seconds to a minute. Yeah, within a few minutes is sort of the time frame that we're looking at. Because again, it's sort of the simplest design for messaging bridges, which is just sort of just trusting the Oracle. So in that sense, it's just very simple to sort of get finality and stuff like that.
That's interesting. We were something that we've kind of been experimenting with a little bit is kind of using these message passing protocols to allow people to create streams across chains. And this was one of the big issues is that if you go through something like originally we were experimenting with Nomad, right? And like if you go through the Nomad bridge, it's like I think a 50-minute time, right? And so we were kind of thinking like, how can we shorten that for the user? Because I mean, it's not good UX, right, for a user to create a stream. We're like, okay, wait an hour, come back and
yeah,
hopefully it'll be across by then, right? I like that idea a lot that you can kind of just do this sort of optimistically, right? Like trust that your Oracle network is going to do the right thing. Definitely have to look into it more.
Yeah, and I'd like to add, so for this UX kind of trade-off, we've been sort of investigating strategies for, if you're moving 100 DAI, you get like 1 or 2 Oracle signers is probably sufficient. It's not like, it's not a huge amount, so we don't need a huge amount of security on it. So maybe something similar for your guys, like if you're doing small amounts, maybe it makes sense to use just sort of a trusted Oracle. And then for larger amounts, you kind of shift more into like using the actual optimistic bridge design, where you have this 50-minute delay, but then you get like stronger guarantees kind of thing. So yeah, we've been looking at this as well.
Yeah, that'd be really interesting, kind of creating a risk framework, right? Like the greater the amount you want to send, then kind of the more security. That's cool. I really like that.
Yeah.
Nice. So I want to come back to some other things related to like how you guys have actually gone about developing this and what some of your development cycles look like. I mean, obviously working in a DAO in some ways might be a little different than working in like a traditional big tech company for shipping new features and things like this. There are a lot of components at play in something like this. But one thing I wanted to also veer into on more of like the product side, new feature side, roadmap side for Maker is Maker's foray into real world assets. Beyond just the pure DeFi ecosystem. Can you enlighten our listeners on what some of the early plans are for real world assets and Maker and what that might look like in the near future?
Yeah, so I mean, that's already kind of getting started and ramping up now. So I believe we had our first real world asset onboarding last year. I forget exactly when it was last year, but we had this company, Success, which is taking out loans, and they're basically an arranger. They're lending it out to other parties and stuff like that, as well as Centrifuge, they're a pretty well-known real world asset company. And so we'll issue them loans and then they'll go out and loan to the end borrowers and stuff like that. More recently, we've had some larger deals come through with specifically Huntington Valley Bank and Société Générale in France. And these are very reputable large banks that we've been just sort of issuing loans to. The HVB one is at 100 million loaned out. So they're a bank, this is their business. They're very good at this kind of stuff. So we just kind of we'll issue them a line of credit, and then they can do what they do best in sort of making a return on that with all the detail in real life. So yeah, that's been coming along on multiple fronts. We've also been looking at using our sort of D3M module, which is basically like DAI liquidity injection into other protocols, investigating, integrating with this with projects like Maple and TrueFi, as well as Centrifuge. This has sort of been progressing on multiple fronts. And I guess another thing I'll add is we've actually just had a recent proposal come from Coinbase institutional, where they are wanting to take 1.6 billion loan and then start investing that into things as well. So yeah, there's lots going on here.
That's awesome. Yeah, it's one of the, in my opinion, more encouraging and exciting developments, especially right now. Bottom of bear market times. It's good to see these kinds of things, right? I think Makers, you guys have been a leader in this kind of space for a while. But something that our listeners might particularly be interested in learning about, right? We have a very developer-centric audience, right? It's called Devs Do Something. A lot of people who are technical see most problems through a technical lens, right? People know that real-world assets and things like that moving into DeFi could be a massive market. And a lot of developers might look at that through a purely developer-oriented lens. I think that there's a lot more to this than just technical specs, right? But are there any interesting technical considerations when it comes to supporting real world assets on Maker?
Yeah, and I mean, I come from sort of the similar developer background. I'm learning a lot of sort of the more traditional finance type stuff as I go. So I get the need sort of, or at least the desire for having everything in smart contracts. And actually, I think this is a good way to go as much as it's possible. But when you're dealing with the real world, you have to delve into the world, the legal world, right? Which is sort of the real world version of smart contracts, right? So bridging these two things is basically what we're working to do right now in DeFi as a whole. But the opportunities here are just so huge, and it's like I'm in the space to basically change the world. So in order to do that, we're going to have to get into the messy details of integrating with the real world and with all the legalities and stuff like that.
And what has that experience been like as someone that comes from a more technical background, diving into this other stuff, right? This messy world of, I don't know how much you're involved with, maybe on the BD side. Maybe there are other people at Maker that do more of the BD, but I've seen you in governance forums and things like that. You do participate in a lot of those discussions. And also you've had to learn probably a lot of legal things, right, to be effective. So if let's imagine you have a group of developers listening to you right now that are maybe elite smart contract developers, but it's time to really figure out how we can make a product interface with the rest of the world beyond just blockchains. What advice would you have for them for exploring some of these other messy things that aren't just diving into the code?
Yeah, I would say for me, it's been sort of broadening what is meant by risk and sort of these calculus with that stuff. So a lot of people, or at least some, sort of view these worst case, we have to prevent against worst case scenarios all the time. And it's really hard to actually get anything useful done if that's your attitude. So I think to me, it's always about identifying the risks, sort of weighing how sort of likely worst case scenarios are, and protecting yourself as much as you can with debt ceilings and stuff like that. So this sort of strategy, it's sort of a middle ground strategy. And with risk, there's all kinds of different risks, right? So it's like, if you're just purely have ETH as collateral or something, you have a lending protocol like Maker or whatever, and you just have ETH as collateral, there's risk there, right? There's market risk. You can have a huge price drop in ETH, and then suddenly you're underwater and you have to cover the bad debt. That's just one type of risk. There's counterparty risk where you're using USDC as your collateral or something, right? And now you have a trusted party. There's legal risk. There's all kinds of. It's all just different kinds of risk, and so to do a technical risk as well, actually, for your developers. Yes, so there's always smart contract risk. We need to remember that. So I think it's just important to keep in mind that these are all just risks, and they should all just be taken into account into the calculus of how much you want to expose yourself to various collateral types and stuff like that. So it's just, I would say best advice, get rid of the all or nothing sort of attitude and just sort of take a more nuanced view of things. And I would also recommend learning what sort of is actually backing a lot of the stuff. So like ETH is really easy because it's like, it's intrinsically part of the chain. It's probably the most decentralized asset you can have on Ethereum, almost certainly. But understanding every other asset sort of at scale, ignoring sort of low cap ERC20 tokens, they're also pretty decentralized. The rest of the assets at scale are sort of, they're backed by something usually off chain, or there's custodians and stuff like that. And just sort of identifying what these are and understanding what the risks are, I think is helpful.
That's really interesting. Managing risk properly and understanding there are more risks than just smart contract risk. That's good advice. Is there anything that you've read or any resources you've found that have been really helpful in thinking through some of these kinds of real world risks?
I mean, this industry is so new, so it's not like there's like a go-to resource. I find I just follow people who think about this stuff a lot, who are experts in their fields. I just sort of follow them on Twitter and, just read what they put out as much as I can, or even just talking to people who, my background is entirely programming, so I don't know what the details of the legal risks even are for within Maker, but there's another team working on that. So just talking to them and sort of understanding, just building your own understanding, I think is the best way to do that.
Totally. Are there any good Twitter follows or individuals in the space that you'd like to call out?
Yeah, I would say if you're interested in sort of this how to look at all this accounting and banking and stuff like that, Seb on the strategic finance team, he puts out a lot of posts like on Twitter and stuff like that, and in the forum. I find it very helpful for sort of wrapping your head around all this stuff. So I think he has more of a TradFi background, and he's connecting it to Maker specifically. So yeah, he's a good follow.
Yeah, I'll put a link to maybe some of his posts in the show notes for this episode so people can read. Okay, so shifting back into some more of the pure engineering items, what is it like to be working at a protocol that has a lot of, you guys, everything is open, right? Like everything, every decision, every like thought process, it's all open, right? Which is great for people that want to get involved and learn. But I'd imagine that it also can be hard to come to consensus on decisions and figure out what to build next. I guess this is a bit of a broad question. I can drill that into specifics here. But what does like the development process look like for, say, a new product or thing within the Maker ecosystem? Can you enlighten us as to what that might look like?
Yeah, so I think the general flow of this, the DAO is definitely more of a political beast than sort of a traditional company. But it's usually more for arriving at a consensus on what to do next. So, for example, with say the multi-chain roadmap, this was sort of presented as what protocol engineering is like sort of a strategy for going multi-chain and stuff like that. This was presented to governance, and governance sort of approves this, and then we can kind of within our team and the other teams, basically coordinate more like a company, like where we have our tasks. They've been approved by governance, and we can sort of just start executing on it like you would any other company. That's sort of how it works. Yeah, within my core unit, it looks very similar to more traditional company. It's kind of separate from the DAO a little bit. Our main interaction point with the DAO is what's called the core unit facilitator. This person is responsible for sort of administrative duties, producing reports, transparency, that kind of stuff, and reporting to the DAO. Well, the rest of the team is, a lot of the time just heads down, delivering results. And this is similar to for all the other core units. So it's kind of this mix between more traditional company style and the DAO more political style.
Nice. And within your core unit, right? Let's use the example of the multi-chain maker or maker teleport or something like that. What does the development process typically consist of? I mean, I'm assuming you'll get your main directive from the proposal and thing that was passed through the standard governance process. But when it comes to the tactical building of the new contracts, like, for example, building those like slave instances that can be deployed on those other chains, what does that look like? Is this like you have cycles, you have sprints? Is it some kind of agile methodology? What does that tend to look like?
Yeah, within my team, it's fairly agile development cycle. We just sort of usually do a fair bit of research ahead of time. And then if once we settle on sort of a design, we just start executing. The team is fairly heavily weighted towards senior engineers, so people can like fairly well manage their own time. We don't need sort of as strict sort of structures. So the agile style fits us pretty well.
Nice. Yeah, no, I think that makes a lot of sense. And it probably is helpful to have mostly senior devs on the team. I'm sure that does speed things up. I had a question from a team member of ours at Superfluid. I put out some feelers for I said, hey, we got Sam coming on. What would you ask him? And a question I got from one of our protocol devs was, when you're thinking about one of these development cycles or you're going through your process, what do you tend to prioritize when considering trade-offs, right? Do you look hard at security? Do you look really hard at maintainability long-term and readability? Are you really looking deep into gas golfing and gas optimizations because this is going to be used so much, and a lot of things are going to be interacting with L1 Ethereum? I'll just let you answer that question as is, but would love to understand how you process different trade-offs like that.
Yeah, so for us, security is always the highest priority. It doesn't matter if your contract is fast, if it gets hacked. It's by far the highest priority. So everything else is kind of secondary to that. After that, I would say this balance between code readability and sort of gas golfing, where we would usually do first pass where you kind of code everything out such that it's the sort of the nicest for code readability and stuff like that. Then you would do sort of a second pass where you're looking for very hot paths. We don't optimize overly everything. You more identify where something's going to be used, such as say the transfer function on an ERC20, very heavily used. So you would heavily optimize that for gas usage. So yeah, that's kind of how I look at that usually. But everything's a balance. I don't think you should optimize too heavily for anything in particular.
Yeah, I think that approach makes sense, where you have security that's prioritized, right? We actually had Nicolas Venturo, a protocol engineer at Balancer, on last week. And one of the things he said is that, they've paid out bug bounties before, specifically as a result of being too cute and too crazy with gas golfing, right? Which is, it's hot. It's cool for Twitter, right? It's fun for Twitter, right? But it is, it can be dangerous if you're not careful about it. But with the caveat there of saying, all right, yeah, if someone's going to call, if millions of people are going to call transfer, over the lifetime of this contract, yes, let's optimize the hell out of the transfer function, right? I totally understand that. How else do you guys look at security? I mean, do you I'm assuming you guys obviously have audit processes and things like that, but do you have any other general advice for smart contract developers on how to think about smart contract security?
I think kind of as an individual, the best thing you can do is just sort of learn what the anti-patterns are and just avoid them. Sort of Maker's sort of had strategy that's kind of been different than a lot of the wider DeFi ecosystem, where people often use proxy upgradable contracts and stuff like that. And Maker's been firmly against that from basically day one. And it's like you find yourself kind of tempted to use this stuff sometimes, but you do need to kind of recognize these as anti-patterns. Sometimes they're useful, and I'm not saying never use this stuff. Be aware of like when you should use something because it makes sense, even if it is potentially kind of a general anti-pattern. And other things, just like you need to just identify danger zones, right? Like where you have, say, reentrancy vectors and stuff like that. Just really, really be careful and sort of learn what these things are. And I mean, part of it you just kind of learn as you go. I think it's like you can just read a page and you're good with everything. There's like sort of lessons learned. Maybe reviewing previous hacks is a good way to learn about where these things come from usually, because a lot of them are fairly sort of similar blunders, I would say, and with the code design. I would say that's a pretty good strategy in my view. For the team-wide stuff, we go through I would say the best in the industry sort of a review process. It's very extensive. Like we're developing code for sometimes years at a time. It's a very long process, but for good reason. I mean, we're securing what is it, 10 billion in assets right now. So like we have to go slow. We have to be methodical. We do many rounds of team review, many rounds of audits, and only when everybody's feeling like we've we're exhausted, we've reviewed this so much, we're feeling super confident about it, the auditors are super confident about it, like that's only then we'll ship code. And even then we'll have them in sort of initial phases with low debt ceilings, usually if it's new code, to get that sort of Lindy effect.
Mm-hmm. Yeah, I mean, that comes down to risk management again, right? Even the debt ceilings are other I guess version of that. But so I saw Josh started smiling. You probably saw Josh smiling when you said we don't have any upgradable contracts. I
never said that. I said we avoid them.
Okay, correction. Avoid them. That is probably still somewhat of a controversial take in the space, right? Upgradable contracts are everywhere. We use them at Superfluid, right? We make use of that. Can you walk through just the methodology for the avoiding them? I mean, obviously there's the thing where like, all right, these are supposed to be immutable contracts, but I would love to hear the full thought process behind why that's your approach.
And let me say, I'm not like dogmatic about this. I understand there's use for upgradable contracts in some places, and there is trade-offs. So like if you actually are using an immutable contract, such as say the VAT, it's probably the most core contract in Maker, you can never upgrade that. That is set in stone. So that thing was developed, back in Solidity. I think it's even Solidity 4. So it's not optimized. Like it's just like it's very bulky. It's very out of date. The gas cost is huge compared to what it could be if we totally just overhauled it. So that would be what I would consider a downside of not having upgradable proxy contracts. But and so we've actually used proxy contracts for some stuff where we need to be more nimble. One of our features, which is called the crop join adapter, which is responsible for yield farming, which was introduced after Maker was deployed, basically gives the users who lock their collateral in, they'll get it'll deposit it into whatever yield farm for that collateral as well, and then give them the rewards for that. That's a new contract, and we developed that with an upgradable proxy because integrations can change. So I would say actually for when we are integrating with other protocols, I think upgradable proxies kind of make more sense there, especially because other people have upgradable proxies. So, implementations can change and stuff like that. So we need to be able to adapt to that as well.
Right. And I think there's definitely, like you said, there's a place for upgradable contracts. I've kind of been making the joke lately that, humans have been writing buggy software for decades, and then somebody had the idea to make them immutable, right? So, I think there's security benefits. Of course, you can, update things if something goes wrong. And then, of course, it's good for like rapidly iterating, right? Because that's a lot of sort of this like tech philosophy is that like, we can rapidly iterate and experiment and try new things, right? And you don't really have that with immutable contracts. But again, it is like, I do think it's important to limit it as much as possible as well, right? Because then you end up in these situations where, if you want to get to market fast, what you can do, right, is you can kind of put this out in an upgradable proxy, and if something goes wrong, you can try and patch it, right? And I think that's responsible for a lot of the recent exploits that have been happening across the industry as well. Like obviously, it's not the sole thing, but I think it's really important to not just move fast and break things when it comes to smart contracts, right? Especially when you have large TVLs, like, it's especially bridges, right? Those are like, non-consensual bug bounties at this point, right? So you want to, I think it's really, really important to like take your time as much as possible. And I really like that maker approach of like, you build this out and you kind of like iterate and you send it through the team, right? And you get as many eyes on that code as possible. Because like audits help, right? But like at the end of the day, it really is just getting as many people on it as possible, because everybody has a sort of different perspective on, like they kind of like have a different eye, right, for spotting different issues and vulnerabilities. So yeah, I really like and I like hearing about this process.
Totally, yeah. I second the move fast and break things sentiment. It's a bit of an issue here. A couple of other questions specifically like on the technical side, and then we can get to the couple of general things we tend to ask to wrap things up. Another member on our team was looking through your contracts the other day. Again, I let people know that we're going to do this. And one thing that he asked, he's on our developer experience team where he like helps write our tooling and things like that and thinks through how our contracts can be readable to the public and other developers. And one thing he wanted to understand is how your team thinks through naming conventions for contracts that tend to be extremely visible to like the rest of the industry, right? Where people are going to go in and read it, whether it's auditors or like other individual devs that want to integrate something. And I think it'd be interesting because we have a lot of internal debates about what we should name stuff. It'd be interesting to understand how you think through that process.
Yeah, the hardest problem in computer science is naming things. We all know this. So I guess for like very low level contracts and stuff like that, it's usually just the author will come up with a name, and people can check it and be like, oh yeah, okay, does this sound good? Or it's often whoever's authoring it just comes up with a name and they're like, okay, it's a good name, we'll just go with it. For more public facing stuff, such as, for example, the peg stability module, that's pretty well known. That was sort of proposed from the forum initially by the Maker Foundation back in the day. And I was actually the one that built that under the DAO. And so I just, took the name they put out there, and it stuck, and it's well known now. And it's similar, I guess, with the D3M. This is another product offering that's kind of well known in the broader ecosystem. D3M stands for Direct Deposit Module. This one was kind of more interesting because I think Stanny and I worked on that, Stanny from Aave. And so I actually initially called it a direct deposit module, and then Stanny called it the direct deposit module, but he put in brackets D3M, and then it just sort of took off under the D3M name. And so, if that's what everybody's calling it, there's no need to fight that, in my view. Just accept it, and this is what popular parlance knows it as, basically. So yeah, that's sort of how I look at it.
Yeah, no, some things take on a life of their own for sure, right? That's interesting. One other thing I think that I really like to ask people in your position who see a lot of code, right? You're probably reading other people's code in your team a lot. You're probably maybe for fun, like occasionally looking at other contracts and things, seeing other design patterns. Are there any optimizations, little mini instances of optimization in terms of gas, or like just really good, clean design patterns that you have either implemented into the Maker contracts that you've seen somewhere in the Maker contracts that you've seen elsewhere in the space that you wish more people would either take a look at or adopt?
Yeah, there's actually a number of practices, and me coming from video game background and stuff. This stuff is not normally what you would do if you're doing sort of a more traditional development style. So I think a big one actually that I find is reducing inheritance. We actually copy and paste code fairly frequently. Like code says it's like, admin access or something. You stick this on almost every contract, but we actually copy it into the contract itself to avoid inheritance. So we do inheritance a little bit sometimes. At maximum, we'll do maybe one level if it like totally fits. But having everything even copy pasted into one contract is like, it makes it so much easier to read. You don't have to like jump between contracts and like sort of context switch mentally when you're reviewing it. And so it also kind of like it removes a lot of these I guess potentially mistaken assumptions you put on like when you're looking at some function that it's like I don't know, maybe like the safe transfer or something like that, right? You have all these assumptions in your head, but it's like it's doing all this stuff in the background, and you're not like maybe your mental model of what's going on is not exactly what's going on in the library or whatever. So having the code as inline as much as possible, reducing the amount of like libraries and inheritance and stuff you're pulling in, I find is just super helpful for making it readable. Another thing, it's like, I don't know, sometimes I have mixed feelings on this, but the Maker protocol is always kind of famous for having these weird abstract variable names that are very small. I don't know, I kind of like it. I didn't necessarily like it at first, but it's been kind of growing on me, just coming up with these weird abstract names like flop and flap and frob. And I think it's nice once you get used to it.
That's cool. Yeah, Josh was sitting there going, "Oh, that sounds nice to copy and paste some code so I can read things."
Yeah, it's so I mean, I've recently started doing like security reviews and like bug bounties and things like this, right? And I've noticed like there's a really big difference between those teams that like really hard commit to these inheritance patterns, and then ones who do things like copy pasting or even like library patterns, right? Like I've seen heavy use of libraries to kind of reuse code like when possible, right? But anytime that it's just a single contract, you don't have to jump to other files. You don't have to worry about anything else. I think that's really cool. Like Soulmate does this very well, I think, right? Like it's you can go to each function and know exactly what happens there. In terms of the abstract names of those variables, though, so is this like are these like acronyms for something that you kind of work with, or is it like is there like basically is there an intuitive way to kind of like figure out as somebody who's reading the code like what all of these variables mean?
Well, I mean, I can't speak for the original like variable names in the VAT and stuff like that. This is the stuff of lore. Original DAP Hub guys who are mostly off the project now. Who knows where they are? A lot of them, and they were the ones that sort of made a lot of these names. So you'll have to track them down and ask them. I think, from my understanding, I think they're just completely abstract, but maybe kind of loosely related to what they're doing in a little bit as much as you can, I guess. Sometimes I make up names that are kind of like, it's a little bit artistic, I guess. You're just like kind of coming up. This name feels like it kind of fits with the action that's going on or the variable or whatever. And yeah, that's kind of how I do it.
Cool. A little bit of like arcane lore there. That's pretty cool.
Yeah.
Okay, so a couple of final questions for you here, Sam. One that we like to ask, just because it tends to be interesting for people that are listening, looking for projects to work on, is let's say that someone sits you down and says, all right, Sam, you got to build smart contracts. You got to build some kind of application, or you got to write code for the next 6 months. But for whatever reason, you can't commit any code to Maker for the next 6 months. You got to do some other thing. What would you spend your time on, and what would you look at working on?
Yeah, so it's pretty easy for me because like all my off Maker time I spent making like MEV bots. I found that like really fun. Just it's super competitive. It's probably like last time I did it was maybe a year and a half ago, so it's just a lot easier back then. But it's kind of like this weird competitive camaraderie with the other. I guess the term for this is now searcher. It's a lot of fun. And, you can make some decent money doing it. So, yeah, I enjoyed doing that when I was outside of Maker.
That's really cool. So what's kind of like your favorite form of this? Like, did you kind of like chase long tail or more like, arbitrage liquidations? What was your cup of tea?
Yeah, actually, a lot of it was centered around Maker liquidation. So, I mean, even though it's outside of Maker, it's kind of related because like I have like fairly high domain knowledge there. So just supporting the liquidation system felt like a good fit. So I've kind of worked there. But I mean, the problem is you have to be on it all the time because you can maybe, if you've got some alpha, you can maybe take advantage of it for a couple of weeks if people are really unaware. But, eventually somebody's going to have more time than you and going to be able to basically just outcompete you in one way or the other. So you have to be in it all the time. And like I'm focused on Maker mostly, so I just don't have the time to be devoting to this full time.
Yeah, definitely. And even, I mean, coming from, a bit of like a competitive, online multiplayer gaming background as well, I kind of see some parallels here of like, it's just this high speed PvP game, just going back and forth. It's cool stuff.
Yeah, it's a lot of fun for sure. I mean, sometimes you even get little messages where you're like competing with one guy and like you're you're just watching their EOA, see what code they deploy, kind of look at what they're doing. And sometimes you get little messages. The person's just like, you beat them. And then they're like, there's like they get a revert message or something. And it's like, stop front running me, you ass, or something like that. It's just fun.
Yeah, there was a really good one on, who did it? I want to say it was DeFi Cartel that built up that Salmonella token. They basically just wrecked like a sandwich bot. And they sent a little message with some ether, they're like, oh, you caught me sleeping or something. It's like, that's just so cool.
It's fun.
I love it. Yeah, MEV is fun for sure. This is a little more high level, right? This is meant to just get your high level thoughts on where we're all going as an ecosystem. Let's say that 10 years pass, it's 2032, and there's a picture of what crypto looks like in the year 2032, right? What do you hope for this space? What do you hope for Maker? How do you hope things shake out over that next decade-long period?
Yeah, I mean, to me, there's kind of two paths. We're either successful and just the entire world economy runs on blockchain and stuff like that, and it's so integrated with everything, you're just completely unaware, kind of like how the internet is right now. It just, everything's on the internet, but you don't really notice it anymore because it's just everywhere. That's sort of the success case. I hope we go down that route. And the other scenario is sort of just we get this extreme regulatory backlash or something like that. And it just is forever sort of a niche product. I'm not super interested in that. It's one way things could go, but I much prefer these sort of change the world type scenario. And for Maker, for me, I would like to see it become a credibly neutral alternative to the world reserve currencies of fiat today.
Well, we do too. So we hope it happens. And listen, we really appreciate you coming on today. I think this was a fantastic, not only overview on some of the things you're working on at Maker, but also you provided a lot of insights into how you guys do things. You have a great engineering culture, I think, at Maker. At least that's what we see from the outside. And it was great to see you give some developer specific alpha to those that tune into this. So thank you for being here, Sam.
Yeah, happy to be here. Thanks for having me.